In this tutorial video, we have a Jamb Past Question on calculus. We are asked to find the derivative of this function given. Now, how do we solve for this? For more on this tutorial video, you need to subscribe to this channel. Solution. For you to solve this question of differentiation, you need to employ what is called the composite function method of differentiation. And that composite function method says the y all over the x, which is what you are looking for, is equal to the y all over the u multiplied by the u all over the x. So once we do this, we've been able to resolve this. We now say let u be equal to 2x plus 1. That means the whole of this inside. It then means that y is equal to u raised to the power of 3. So the first thing to do is to find the y all over the u, which is this. We come over to this side. The y all over the u is equal to 3u raised to the power of 3 minus 1, which is equal to 3u squared. The next one to find is the u all over the x, which is this. So the u all over the x is equal to 2. Because if we differentiate this, we get 2. We differentiate 1, we get 0. All we need to do is to write our value for the y all over the x. The y all over the x is equal to the y all over the u. The y all over the u. What do we have as the y all over the u? We have 3u squared. So write it out. 3u squared multiplied by the u all over the x. What do we have as the u all over the x? We have the u all over the x is equal to 2, which is 2. It then means that we can write this as 6u squared. 6u squared. And what is u? We have to recall that u, like we said before, u is equal to 2x plus 1. So since u is equal to 2x plus 1, we just impute the value of u into this. It then means that our final answer, which is the y all over the x, is equal to 2x plus 1, which is our u, raised to the power of 2. So this becomes our answer to the given question. We have succeeded in finding the derivative of the function given. So for more on this tutorial video, you need to subscribe to this channel to get more questions on calculus.